Okay, so this hint is for problem 3 in the current homework 7. So the way this problem is set up, you just go back and draw this circuit, which is the equivalent circuit diagram as per in the textbook for a Colpitt's oscillator. So this is what you have. You have RL, C1, C2, V1. This is defined as a voltage V tank. V1 looks at an effective resistance of 1 by capital GM. And this tank is being fed with the current of capital GM times V1 current, and is defined as C1 by C1 given to C2. Now you have been told to do that GM is now equal to GM0 e raised to minus j omega TD. Now what is GM0? GM0 is the basic definition, which is 2I bias by V10, where V10 is the amplitude of the sinusoid at this point. You can then write the equivalent circuit diagram as follows. You can make this as GMV1, which is feeding in RL, C equivalent to C1 parallel C2. So C equivalent is C1 C2 by C1 plus C2. I'm sorry, C1 and C2 in series. And because you have this thing here, what effectively there's an impedance transformation, and looking in this direction, you see now an effective resistance, or impedance, which is 1 by n squared GM. So let's write some conventions. If I now write my V1 to be V10 e raised to j omega t, because it's sinusoid, and write then V tank is V tank 0 e raised to j omega t, where V tank 0 is the amplitude, then V tank 0 is V10 by n e raised to j omega t. Therefore GM V1 is GM0 e raised to minus j omega t d V10 e raised to j omega t. So then it all simplifies down to GM0 V10 times e raised to j omega t minus td. This is 2I bias. I can write 2I bias e raised to j omega t minus td. So the case that you now have is that you have a current source of 2I bias e raised to j omega t minus td feeding a tank, which is resistance R, inductance L, C equivalent capacitance. The voltage across the tank is V tank 0 e raised to j omega t at the oscillation frequency, and then you have this impedance R dash, which is 1 by n square GM, which is 1 by n square GM0 e raised to j omega td. Now here you can make the assumption that omega td is much smaller than 2I. So then what basically happens is you can write e raised to minus j omega td as cos omega td minus j sin omega td. And because omega td is much less than 2 pi, this is nearly 1, and this is sin theta tends to theta for very small theta. This tends to omega td. So because you have that, the effective impedance is 1 by this. So the effective admittance is basically n square GM0 minus j omega td n square GM0. So this is the net admittance. So that I can represent as a resistance of value 1 by n square GM0 in parallel with a reactance of value 1 by j omega td n square GM0. So now I can draw this final circuit diagram, where I have this current source of 2I bias e raised to j omega t minus td feeding into resistance R, L, C equivalent. So I can write admittances of this is 1 by R, of this is 1 by j omega L, of this is j omega C equivalent, of this resistance as n square GM0. And I'm talking about admittances. So you now have this condition. Now in oscillation state, basically you'll have two equations, and you have to solve for two variables, because you have to solve for what V tank 0 is and what omega is. So what are the two equations? Well, the two equations are, the main equation that you have to solve is just admittance equal to admittance. That is, what is the net admittance here? It's the sum of all these, so that's the right hand side. It's basically the sum of all this. It's equal to the admittance that you get. Why? Because you have the admittance as 2I bias e raised to j omega t minus td by V tank 0 e raised to j omega t. So the two equations that you form is phase of this is equal to phase of this, which is a sum of all these. So that will give you an answer for what omega is. Then you do magnitude of this is equal to magnitude of this, and that's going to give you V tank 0. So yeah, that's the hint for this problem. Thank you.